Okay, solve, simplify, and factor. I want you to take 1 minute and I want you to write down anything that you can think of about solving, simplifying, and factoring. So I'm going to give you 1 minute. Solving, simplifying, and factoring. You can use Professor Google. Solve, simplify, factor. Okay, who came up with something for solve? What did you say for solve?
You're trying to find out what x is equal to.
Okay, find out what x is equal to. Good. What else? What else about solve? Final answer? Is that what you said? Good. Okay, it's your final answer. What else? Solve. When we're talking about solve, what are we talking about? What kind of math are we talking about? What sign are we going to have when we're solving?
Addition and subtraction.
Okay, addition and subtraction, we can actually have that when we're simplifying also. Equal to. Okay, so we're going to have an equal to. Now, you may also have a greater than, less than. So all of those take place when we're solving. And this is the big thing right here. When we're solving, we are trying to find out what x is equal to. And we are going to have an equal sign, a greater than, a less than sign, a greater than or less, or greater than or equal to sign, or a less than or equal to sign. We are going to have one of those when we are solving. We solve equations, we solve inequalities. Okay, so we solve equations and we solve inequalities. Okay, we have something that looks kind of like x equals 4. X equals 4. Okay, and there's rules that we've talked about when we've solved equations. Okay, like we can multiply everything by the LCD when we are solving an equation, and that's because we have the equal sign. What do I mean when I say simplify? What does the word simplify mean? Okay, take it as far as I can go. I like that. Okay. What operations are we doing in Shay? 4x squared times y. Okay, so that is exactly right. Now, how does this 4x squared times y look different than this x equals 4?
There's no equal sign.
Okay, there's no equal sign. When we're simplifying, there's no equal sign. And that's an important distinction. So a lot of times when students are working on this particular chapter that we're working on, they get confused. When do I factor, Alicia? When do I simplify, Alicia? And when do I solve? Okay, so here, I want you to kind of see the difference between solving, simplifying, and factoring. There is no equal sign when we are simplifying. There is no equal sign when we are simplifying. We are combining. We are combining. Okay? We are multiplying. We are dividing. We are combining when we are simplifying. Okay? This 4x squared y, that's what an answer may look like. When we're simplifying, we might have an answer that looks like that. Okay? When we are solving, we may have an answer that looks like this. The x equals 4. There's a difference between solving and simplifying. Okay? I like the word combining. I like that word combining. Whoever said that. I also like take it as far as you can go. Like terms are also an important part of simplifying. Okay? Now, factoring is what we're going to start doing today. Factoring is what we're going to do today. What comes to mind, or what did Professor Google say about factoring? Factoring. Shay? Okay, and it's actually, we use FOIL when we're simplifying. Okay, we're going to do the opposite of FOIL when we factor. Okay? Caitlin?
I think about like it being like a binomial or trinomial, and you need to find like the common. It's almost like the least common denominator in a way,
okay.
But not really. You're just like looking to take out something.
That's greatest common factor that you're talking about. That's what you're talking about. And I like what she said. Looking to take out something. Okay? I like that. Looking to take out something. Now, we are going to use the properties of FOIL, just like Shay said. We're going to use the properties of greatest common factor, but we are working backwards. We are doing the opposite of simplify. Now, a lot of times what happens with students is they will factor everything, then they'll multiply it back together because they're like, oh, that doesn't look right. So factoring, we are breaking it down. Breaking down. That says done, but you can't see it anyway. That should say breaking down. One day I'm going to buy it. I'm supposed to get a new computer. And when I get a new computer, I'll buy it, and you won't have to look at that Doceri desktop trial anymore. Okay? This says looking to take out something. This says working backwards. This says breaking down. That's what we're doing when we're factoring. The answer to factoring looks like your original problem in simplifying. Okay? And your original problem in factoring looks like your answer when we're simplifying. So we are doing the opposite here that we did right here. Okay? So it is important as we go into factoring that you understand the difference between solving an equation, simplifying expressions, and factoring. Those three terms are important. Okay? Okay, let's start this fun stuff. Okay. GCF stands for greatest common factor. That's what GCF stands for, greatest common factor. We have used greatest common factor a lot in simplifying fractions. Okay, when you simplify fractions, you look at what goes into both the numerator and what goes into the denominator, what number goes into both. We're going to use that same principle here. We've got 3x to the fourth plus 15x to the third minus 21x squared. So what we are going to look at, the first thing we're going to look at is we're going to look at our numbers. And we're going to say, what number goes into 3, 15, and negative 21. I am only dealing with my numbers. What number goes into all those?
3.
3. Okay, so I'm going to write that down. Now, the next thing that I look at is I look at my variables. So in this one right here, I have x to the 4th, I have x to the 3rd, and I have x squared. Now, there is an x in every single one of them. There's an x in every single one of them. So I know that I can take out at least an x to the 1st. But now what I want to look at is what is my lowest exponent? X squared. So I can take an x squared out of every one of them. Okay? So 3x squared is my greatest common factor. There is a 3x squared in every single one of those terms. Okay? So now what I do is I ask myself, 3 times what gives me 3? 3 times what gives me 3? 1. Now, do I have to write that 1? I don't. I don't have to write that 1. Then I have x squared times what gives me x to the 4th? X squared times what gives me x to the 4th? Good, x squared. Okay? So there's 2 steps. You deal with the number, then you deal with the variable. Okay? Here, we're going to deal with the number, the x variable, then the y variable. Okay? Now, 3 times what gives me 15?
5.
Good. X squared times what gives me x to the 3rd?
X.
Okay? 3. Be careful on this one. 3 times what gives me negative 21? Excellent. Now, x squared times what gives me x squared? It is times 1, okay? So it's actually negative 7 times 1. Do I need to write that times 1? No. Actually, don't write the times 1. But I want your brain to know what's going on. Now, this is your answer. And it looks uncomfortable because we just did a whole bunch of problems where this was the problem and you were told to simplify. Okay? That's the difference between factoring and simplifying. When you're factoring, you are getting what looks like the original problem when we were simplifying. We are doing the opposite of simplifying. That would have been a good thing for me to write down under factoring. It's the opposite of simplifying. Okay? Good. Okay, let's look at the next one. We've got 8x to the 3rd y squared minus 2x squared y minus 12x y squared. Now this looks intimidating. It looks intimidating, but we are going to break it down. First thing we're going to look at, we're going to look at 8, negative 2, and negative 12. What number goes into all of those?
2.
2 does. So that's the number that we're going to write on the outside. Then we are going to look at the x to the 3rd, x squared, and the x. Raise your hand if you can tell me what is common to every one of those. Raise your hand. The x is common to every one of those. I can't take anything bigger than x out. I can't take x squared out because my lowest exponent is x to the 1st right here. Okay? So I'm going to write x. Okay? Oh, you're good? Okay?
Can you also take out a y?
You also can take out a y. Okay? And you can only take a y out because we have y to the 1st right here. Okay? You can't take a y squared out. You've got to deal with your lowest exponent. Okay? Now, there's 3 different things that we're doing here. So don't try to skip them. You've got 2 times 4 gives me 8. X times x squared gives me x to the 3rd. And y times y gives me y squared. I want you to think about them completely separate. In your brain, say 2 times what gives me 4? I'm sorry, 2 times what gives me 8?
4.
4 does. X times what gives me x to the third?
2.
X squared. X squared. Y times what gives me y squared?
Y to the first.
Y to the first. Okay, so now we're going to do it again. Now, don't forget your negatives. 2 times negative 1. And I go ahead and I would encourage you to go ahead and write that negative 1 in this situation. You could just write the negative and you still would be 100% correct. But a lot of times that visual of that negative 1 is helpful there. If you want to take it out in the end, you can. Okay, then I have x times x gives me x squared. Then I have y times 1. And you don't want to write this 1 because that confuses you. But that's what's happening here. 1, this y times this 1 gives me that y. Okay? But you've already got that covered with your coefficient. So you're just going to leave it as negative 1x. Okay? Okay. Then I have y times y, right? So, y times 1. And so I leave that one also. Okay, and then my last one, 2 times negative 6 gives me negative 12. X times x, I'm not going to write anything. Then I have y times y. Okay? Okay. This is called factoring out your greatest common factor. This is factoring out your greatest common factor. And the first thing that you do when you are factoring is you look and see if there's something common to every single term. That's the first thing that you do. If there's something common to every single term, you go ahead and take it out because then you are dealing with smaller numbers. So factoring out the greatest common factor is the first step in all factoring. Is there a greatest common factor that I can take out of everything? Now, the next one that we're going to do is called factoring by grouping. Factor by grouping. Yes, ma'am. Sure. It is asking us to factor. What we're doing right here is factoring. Good question. Okay? Okay. Now we are going to factor by grouping. After we've asked ourselves, can I take a GCF out of every single term? The next thing I ask myself is, can I factor by grouping? Can I factor by grouping? In order to factor by grouping, I must have 4 terms. Okay? In order to factor by grouping, I must have 4 terms. If I don't have 4 terms, I got to find a new way to do it. I can't factor by grouping. Okay? Now, the way that I factor by grouping is going to be similar to factoring the GCF out. I am going to break it down into 2 sections. So I'm going to look at this first section right here. I have AB squared minus 4B squared. And I say to myself, what is common to both of those terms? So it's similar to factoring out the GCF, but I'm only doing it in 2 of the terms. What is common to both of these terms? B squared. Good. So I have B squared. Okay, and then I have B squared times A. Then I have B squared times negative 4. So I have focused on the first 2 terms. Only the first 2 terms. Now, I'm going to focus on these 2 terms. I'm going to say, what can I take out of both of these?
The 3?
I can take a 3 out. Good. Then I'm going to have a minus 4. Now, a couple of things that you need to recognize with this right here. Do you see how I have a minus 4 and a minus 4 right there? They have to be exactly the same. They have to be. If they aren't exactly the same, then you can't factor by grouping. And sometimes that happens, and we have to do a new kind of factoring that we really focus on in Math 144. Okay? So, this shows up twice. I write it down once. A minus 4 is one of my binomials. Now, the second thing that happens, this b squared plus 3 is my other binomial. B squared plus 3 is my other binomial. Okay? So a minus 4 times b squared plus 3, that is factored, that I have factored that by grouping. Now, did anyone write down b squared plus 3 times a minus 4? Anybody write it down that way? Okay, you can. 2 times 3 is 6. 3 times 2 is 6. You can write them in any order. Okay? The one thing that you have to do, this plus has to be here, and that negative has to be here. So you could not have b squared minus 3 and a plus 4. That's not the same thing. But having these in a different order is completely fine. It's completely fine. Because you've got your two binomials in a different order. How could I check this if I wanted to? What could I do to check it? Distribute or FOIL. Yes, that's what we would do. Distribute or FOIL. Okay? Okay, let's do another one. Because you use this method quite a bit. Okay? So the first thing we're going to do is we're going to look at x squared minus x. X squared minus x. X comes out of both of those. So I'm going to write x on the outside. X times what is x squared?
X.
Okay. This one is where you can make a mistake if you're not careful. So I want you to raise your hand if you can tell me. X times what is negative x? Raise your hand if you can tell me what that is. Negative 1. Okay? That's correct. It's negative 1. Be careful because we like to lose those negatives. Sometimes we forget about those negatives. Okay? Then, who can raise their hand and tell me what comes out of my next 2? What comes out of my next 2? Yes, you're absolutely correct. 5 comes out of my next 2. Whoops. So then I have 5, x minus 1. Okay? X minus 1 is one of my factors. My other factor is my x plus 5. And this is called factoring by grouping. Factoring by grouping. Okay, can I move off this screen? Because I have one I want you guys to do on your own. Okay, so now I'm going to give you 1 minute to do this one. And I want you to try this one on your own. So the first thing that we do is we look at our x squared plus 2x. I am hoping that you identified that an x should come out of both of those. When I take that x out, I'm left with x plus 2. Now, this one is a little bit tricky because remember, we have to get x plus 2. We have to. If I take a 3 out of that, I would be left with negative x minus 2. That doesn't get me where I want. So this is where trial and error comes into play. So what I have to take out of this is a negative 3. Negative 3. Okay, if you missed that and you didn't see the negative 3, that's okay. Students sometimes miss that the first time around. Negative 3 times positive x gives me negative 3x. Negative 3 times positive 2 gives me negative 6. So if you miss that negative 3, kind of put a star there because that is something that we want to be on the lookout for. Okay, and then my final answer is x minus 3 times x plus 2. Good. What kind of factoring is this? Factoring by grouping. Factoring by grouping. And even when we start doing our more complex trinomials, which is 3 terms, we're going to turn that trinomial into a 4-term so that we can factor it easier. Okay? And that's what we'll be spending most of our time on Wednesday doing, is factoring those more challenging trinomials. Okay. The next one that we're going to look at the difference of perfect squares. Now, with the difference of perfect squares, we briefly talked about this when we were simplifying. You are going to have to be able to identify difference of perfect squares because they don't kind of pop up and you can't follow all the same rules that you do when we're factoring a trinomial. So you've got to be able to identify this. And so one of the ways that we first start making sure we can identify difference of perfect squares is we talk about what a perfect square is. So if I multiply 1 times itself, I get positive 1. 1 squared is positive 1. 2 squared is what? 2 times 2. Okay, 3 times 3. I heard it. 9. Okay, so 3 squared. That's 3 times 3. 4 squared, 16. Okay, 5 squared, 25. 6 squared, 36. 7 squared,
29.
Good. 8 squared. Okay, 9 squared. And 10 squared. Good. Okay, now what I want you to look at, these are the perfect squares. Those are perfect squares. There is a number times itself that equals the perfect square. So you can take the square root of a perfect square and get a rational number. That's what a perfect square is. And all of these that I have circled right here, those are the perfect squares. So the difference of a perfect square is when you have a perfect square here and you have a perfect square here and you have a subtraction sign here. The first term has to be perfect. The second term has to be perfect. And it has to have a subtraction sign. That's what makes difference of perfect squares. Now, x squared is x squared. That's x times x. Okay, y squared is y squared. That's a perfect square. Now, what if I had x to the 4th? Is that a perfect square? It is a perfect square because it's x squared times x squared. It doesn't show up a ton, but every once in a while it will. So x to the 4th, I want to write that down. That's x squared times x squared. I don't think you would see x to the 6th, but just for fun, that's x to the 3rd times x to the 3rd. Okay, so those are all perfect squares. That is uncalibrated, just enough to be super annoying. Yes?
Could you show an example of a problem that might look like a difference of perfect squares, but it isn't?
Good. I would love to. It's a great question. That right there is the number one mistake. Okay? This is not a difference of perfect squares. Why? Because of the plus. It's not subtraction. Okay? That's your number one right there. People see that and they think, oh, it's x plus 4 times x plus 4. Okay? And x plus 4 squared is a trinomial. That was a great question. Thank you for bringing that up. Okay, can I erase my perfect squares? Do you guys have those written down? Okay. So what we're going to do now is we're going to talk about how to solve these. Both of these on my screens are perfect squares, or difference of perfect squares. So the first thing that I do is I'm going to take the square root of x squared. Okay? What times itself gives me x squared? X. Okay? So I'm going to put an x here, and I'm going to put an x here. Okay? So I have taken the square root of my first term. My second term is negative 16. What is the square root of 16? 4. So I'm going to put a 4 here, and I'm going to put a 4 here. Okay? One of these is going to be plus, and one of these is going to be minus. And if we FOIL that, if we FOILed x plus 4 times x minus 4, we would get x squared, and this is a check right here. Okay? This isn't part of the problem. I'm just checking. X squared minus 4x plus 4x minus 16. What happens right here? They cancel because they're opposite. Okay, that's what we're talking about with difference of perfect squares. So you do want to make sure that you can kind of identify those. Okay, do you have a question? No, okay, sorry about that. Okay, now, here I've got a coefficient in front of my x squared. So what is the square root of 4x squared? So I've got 2 and then what? Then 2 and x. So I took the square root of 4, which is 2. Then I took the square root of x squared, which is x. Okay? What's the square root of 25? Good. So I'm going to have plus 5, and I'm going to have minus 5. Okay? The next one that I have, I want you to be careful on this one. 9x squared is perfect, and 36 is perfect. But there is a greatest common factor that I can take out of this. What comes out of 9 and 36? 3 does. Is there something bigger than 3?
9 itself.
9 itself comes out of it. So when you've got your greatest common factor, you want to pull that biggest one out. So that is a great habit to get into. Okay? Always pull your greatest common factor out if you have one. Pull out a greatest common factor if you have one. Okay? So now, this factors to x plus 2, x minus 2. Okay? Okay. This one is a little bit more challenging because it does have a common factor. The first common factor I would notice is my y. My y goes into both of those. There's also a 3. There's also a 3 in your 48. This may be one of those problems where you grab a calculator when you're working on your homework. It's okay. The big thing is that you don't use a calculator when you're doing your practice tests. Sometimes with the factoring on your homework, there's a little bit larger numbers. You're not quite sure what to do with. And so if you use a calculator on that, that's okay. But don't get so comfortable with the calculator that then you're lost on the test. So, but just know that you do have that option if you get hung up on your homework. You can grab that calculator on your phone. Okay? So 3y is 16y squared minus 9. That's what we end up with right there. What's the square root of 16y squared? What's the square root of 16? Good. Okay, so I have 4, and then what's the square root of y? Square root of y squared, I'm sorry. Y. So I have 4y. What's the square root of 9? You got it. So then I have plus 3 and minus 3. Okay? So just remember that when I write your tests, I know that you don't have a calculator. So I will be aware of that. Okay, we've got about 6 minutes left, and I do want to show you this last one. For this one, we are factoring trinomials. And this, typically students remember this part. Okay, we are factoring trinomials in the form x squared plus bx plus c. So when I am factoring x squared plus bx plus c, we don't know the b value and the c value, but what is in front of that x squared? What is, in this situation, what is in front of that x squared? A 1. There's a 1 in front of it, okay? So for these problems that we're going to focus on for the next 5 minutes, there is a 1 in front of that x squared. And so there is a set of rules that we follow because, and it's our a value, okay, our a value is 1. That's what's happening here. So when we factor these, we are looking at the sum and we are looking at the product. Our sum is always the b value. And our b value here is that 8. Your b value is what is in front of your x to the first power. That's what your b value is. So in x squared plus 8x plus 12, what's my b value? What's in front of my x to the first power? Just my x. In x squared plus 8x plus 12. 8. Okay? So my sum, what I'm looking for when I add two numbers together is 8. My product, when a is 1, is my c value. Okay? It's my c value. That's my constant, my number that doesn't have a variable associated with it. What is my c value in x squared plus 8x plus 12? What's my c value? The number that stands by itself. 12. Good. Now, what you're going to do right now is you are going to ask yourself this question. Okay, this is the question that you ask yourself. What two numbers multiplied together give me 12 and added together give me 8. And it has to be both. Okay, you've got to find two numbers added together that give you 12. I'm sorry, multiplied together give you 12 and added together give you 8. So what two numbers added together give me 8, multiplied give me 12? 6 and 2. Okay, so then when we factor this trinomial, it's x plus 2 times x plus 6. Okay? That's how you factor these. Okay? And there's definitely an element of trial and error. Shay. Okay, that's a good question. Sum means added. Okay? Sum means added. So I am adding two numbers together to get a number. And it's always going to be this b value right here. It's the number in front of just the x, not the x squared. Product, we are multiplying together. Product means two numbers that are multiplied together. And it's always going to be this c value right here, what's by itself. Okay? So for our next one, and I always write down my sum and my product. I always write it down. So for this one, my x squared minus 10x plus 24, my sum is what's in front of just the x. So what is that number in front of just the x?
Negative 10.
-10. That's my sum. My two numbers multiplied or added together are going to give me negative 10. My product is my c value. It's that number that doesn't have a variable beside it. 24. Okay? Now, I have a product that's positive. In order for me to get a positive product, I have to multiply two positive numbers together, or I have to multiply two negative numbers together. Okay? There's no other way to get a positive product. My sum here is negative. So my only option is to have some negative number times another negative number so that I can get a positive 24. So I could have negative 8 times negative 3. Does that give me 24? Positive 24? Oh, thank you. Okay, negative 8 times negative 3. Does that give me positive 24? It
Yes.
does, but if I add those two together, does it give me negative 10? No. I could have negative 12 times negative 2. Does that give me positive 24? It does. Add them together. Do I get negative 10? Any ideas? You got it. Negative 6 and negative 4. Okay, so my answer here is x minus 6, x minus 4. There's a trial and error component. There's a trial and error component. For both of these, I have a negative product. I have a negative product. What is the only way for me to get a negative product? A positive number times a negative number. You got it. Keep that in mind when you're doing these. It is to your best interest. Now, I'm hoping that you've already done all of these. I'm hoping you've already done these. That's what we talked about last week. It's to your best interest to do these before Wednesday. Wednesday, we are hitting ax squared. So there's going to be a number in front of the x squared. That's when students, that's a struggle. So if you're not here on Wednesday, watch the video. Like 10 times, watch the video. If you are here on Wednesday, watch the video. Factoring review at 3 Tuesday and noon on Wednesday.